Geometry lesson, hypotenuse leg, HL triangle congruence theorem. We have a warm up here, guys. Why don't you pause the video and hold on. If I'm not mistaken, I believe this triangle should be EDF. Let's see. Let's see if that's right, guys. Uh, this one goes ABC, ABC. So it's going away from the right triangle, right? And then we got EDF. Yeah, I think it's right. Okay. All right, guys, we have this, and then we also have this question, guys. Okay. All right. Pause the video. Okie dokie, we're back, and then here are the answers. Right. And I think the 8 and 16 is fairly straightforward for us, right? In order for us to show that's angle equals side, the part that's missing over here are the two angles. So we need to show that the angle A and E, to use angle equals side. And in this particular case, if we have AC and EF, that here and here, then triangles are congruent by angle side angle. And um, if we had AB is equal to ED, this AB and ED right here, then it will be congruent by angle side, right? And so on and so forth, right? Anyways, let's talk about this. Let's examine the case where the two triangles given, right? So if you have angle A right here, guys, do you see that's right here? And then AC is 6 right here, and the CB is 4. This is we'll come back in a couple of years from now, but we don't know the key is that we don't know this side. So that's complete mystery to us. We only have this angle and this side, and this is 4. Well, if this was 90 degrees, this would be 3. It's a little longer than that, right? So 4 is between 3 and 6. So if we drew 4 this way, we'd have this one triangle. But if you swing it out, they draw it this way, you get triangle that way. So basically, this is showing you that by having angle side, right? Sorry, right. We have angle side, or a lot of books go by side angle, side angle, right? It's not enough information to show that this is one of the reasons why, right? Is that you could create two different triangles for that reason and a few others. Um, you cannot assume that angle side will yield congruent triangles. Okay. Yep. That is it, guys. Is side angle sufficient to prove? Answer is no. Okay. But you might want to consider something else, right? This angle was what? 30 degrees, right? Is there an exception to that rule? So I'm sort of warming you up for today's lesson. All right, let's just head straight in. And I think this right here sort of implies that a little bit. Okay. Because if you think about this triangle, right? This triangle compared to this triangle. Okay. I realize this is part of this right here, right? But if you look at them side by side, what if I had this, and I knew this length, and I knew this length, right? And I knew this. Let's forget about this. Then I'll have side angle, right? What will be the difference in outcome? Just think about that a little bit. All right, guys. Here begins the actual lesson. So, we've learned in the past the different ways to show that triangles are congruent. The first thing that we learned was side angle side, right? And then side, angle, and angle side. And this essentially, angle side was a consequence of angle side angle, as long as, because if we know two of the angles, we could figure out the third angle, right? Look at that, guys. If we have these two triangles, right? Angle, side, angle, let's say, right? But if these two are the same, right? Then this third angle also has to be the same. If that's the case, angle side angle is no different from having angle side. So it's the same idea, right? But now we go to hypotenuse leg, and there's a fifth way, right? We had four so far, and it's called hypotenuse leg, HL congruence theorem. If the hypotenuse and a leg of the right triangles are congruent to the hypotenuse and a leg of another triangle, then two triangles are congruent. Basically, we have this, right? If we have this, then what we're saying is that triangle ABC is congruent to triangle DEF. You might want to write what I just wrote, like around this area. So now, let's think about this for a second. We're going to prove this now. We're given that they're right triangle, okay? And we know, therefore, angle C and F are right angles. Therefore, they're congruent to each other, right? Because we know that the right angles are congruent to each other. So the question is, are they congruent? And here's the thing, though. We could only use what we already know. So we have to use one of these four things to prove that that must be true. Which one do you think is most likely? Now, given this information, there's no way to figure out another angle, right? So we so far have side angle. Because we cannot figure out the relationship of the angles, right? Angle side angle and angle side is out of the question. And then we had side angle side, okay? But in order to use that, I need to know this length. The other option that we have left is side. It's that if I know this side, then I could use side. Looks like I have to somehow show that the B and the E are equal to each other. The question is how, right? Okay. What's the thing that comes to your mind when you have a right triangle? What's the thing that pops into your mind the most? I think that is the key. Why don't you pause the video and try to do this on your own. We're back. And so hypotenuse leg is actually side angle case where the angle is 90. This is a special case of side angle, right? We sort of talked about that, right? Down here, where we don't have side angle, but we actually do. The only exception is if the angle is 90 degrees, right? So here we go. This is how you do it. I just copy everything over here. Boom. That's given. Another thing that I'm going to write down is that I forgot, they didn't write down over here, but if it has a tick mark that's drawn in for you already, it means they're congruent. So that was also given. Right, when you have a right triangle, guys, you have to use Pythagorean theorem, right? So because it's a right triangle, we know that the a squared plus b squared equals to c squared. Hypotenuse squared is the sum of the legs, the squares of the legs, right? And same thing is true for the second one. There you go, we're done. However, this is what we're going to do, right? That's Pythagorean theorem, right? By substitution, I'm going to replace a with d because a and d are the same. I'm going to replace the c over here with f. And you're like, wait a minute. Once you do that, we got two f squares. Set them equal to each other. Boom, I did that right there, right? So f squared is equal to this and this. You set them equal to each other. You can call that substitution, or I actually personally prefer transitive property of equation or equality. And then from here, I subtract d squared, subtraction property of equation. I'm left with b squared equal to a squared, which means that b is equal to e. Oh my gosh, look at that. So we have b and e are congruent. So we got all three sides, right? So here you could have said triangle ABC is congruent to triangle DEF by side congruent triangle theorem. Or you actually could have said side angle side, right? If it's a big if, in order for you to do that, you have to say, right, instead of So you need additional step, maybe somewhere over here, maybe, right? You should have said something like the angle C is congruent to angle F. The reason is that right angles are congruent. If you did that, that would be angle, wouldn't it? Right? So then you have side angle side, right? So in order for you to do this way, you needed that extra statement, right? So that'll be side angle side, congruent triangle theorem or triangle congruence theorem. Either one is okay with me. Okay. All right, guys. So if you want to, so there's a one other deviation which required you to extra step over here. So instead of side, you could go on with side angle side. All right, guys. Here we go. Why don't we practice this? Okay. Determine whether there's enough information to prove that these two triangles are congruent. If not, what do you need? Okay, please explain your answer. And there's another question over here, right? I use two-column proof. This is right angle. Can we show that these triangles are congruent? A hint: when you have overlapping triangle like this, I would actually separate them this way. That'd be right angle. That'd be A, B, C, B, C, D. And these two are the same. What do you know about these two? Right. All right, guys. Pause the video, right? And then we'll go through it together. Okay, guys, we're back. In the first one, we know that these two are congruent by HL. How? Okay, first of all, this is right angle, right? So right angles are congruent. So we got right angle. So if you have a right angle, there's a good chance that you're going to be using hypotenuse leg. Guys, whenever you see this, immediately when you see hypotenuse leg, it has to have a right triangle is required. Okay? So you have to show that something is a right triangle. And then it showed that the AC and BD are equal to each other. That was given to us. That was hypotenuse, H. And the BC is congruent to CB, reflexive property, and that's the leg of the right triangle. Hence, triangle ABC is congruent to triangle DCB by HL, congruent triangle theorem, or triangle congruence theorem. Either one is okay. Now the hard part, I think, is for you to set the correspondence. How do you do that? Well, the way I did it was I started with A, went all the way around to C, where the first and the last forms a hypotenuse, and the middle became the angle, right? Yeah. So I went A, B, C, and I asked myself, what is saying hypotenuse here? This is BD. So that's either DB or BD. We don't know which one is which, right? However, when I go this way versus this way, this seems to make sense. It seems to go in reverse order, right? So if it's BC, and if I put B and a D over here, it'll be BC again here, right? Yeah, so you need to swap. So it has to be DCB. Making sure that they match up is kind of important. Actually, it's really important, right? All right, guys. In this particular one over here, these were all given to us, right? So GJ and JG are congruent by their reflexive property. So it's side. Now, having said it's GKJ, you could either say JHG or GHJ because these two are congruent. And even if you swap them, it's exactly the same. It is an isosceles triangle. Okay. All right, guys. Let's move on to the proof over here. As I told you before, splitting this up, this green and the blue right here into two different ones is important. And we know that the A and D are right angles, right? That was given to us. A, B, and DC are the same. That was the leg. And then BC and CD are congruent to each other by reflexive property, but that was the opposite of the right angle. So they're hypotenuse. I have a hypotenuse and a leg, so I'm done. Triangle ABC is congruent to triangle DCB by HL congruent triangle theorem or triangle congruence theorem, right? All right, guys, we have your turn. Something similar that we did, right? And then we have something similar. Oh my gosh, overlapping triangles. All right, pause the video. Okay, guys, I'm going to show you the answer. If you have any questions, we'll just go over in class. If you could do this on your own, you're in very, very good shape. Okay. All right, guys, that was it. And here's the next one. Okay, guys, I'll see you tomorrow. Okay, bye bye.